In this session, we're going to look at lessons 65, 66, and 67. 66, there's actually nothing to look at, so we'll just do 65 and 67. Lesson 65, we're going to do more on trig stuff. This one's going to be kind of interesting and fun. We're going to have sine x, or bring us to the other side, equals square root of 1 minus sine squared x. Now what we're going to do is we're going to square both sides. When we do that, we get sine squared x equals 1 minus sine squared x. Bring us to the other side. We're going to add sine squared x to both sides. When you do that, you get 2 sine squared x equals 1. Divide both sides by 2. We get sine squared x equals 1/2. Bring that to the other side. We get sine squared x minus 1/2 equals 0. Now we see that this is the difference of two squares. And what we'll do is we'll do parentheses, sine x, we'll get negative 1 over root 2 and positive 1 over root 2. In order to solve for these, we'll have sine x equals positive 1 over root 2 and sine x equals negative 1 over root 2. Now we know these as 0.707 or negative 0.707. This is going to be in the 45-degree family. Now remember, there's always 2 of these and always 2 of these, so it's going to be all 4 of them. So it's going to be 45, 135, 225, and 315. And so that's actually, wasn't too bad. This was actually a little more involved than it was actually getting the angles there at the end. Here's another problem, a couple interesting things to look at here. Not too difficult. They actually set the problem up where you get to go ahead and solve for it. So in this one, you'd have tan x equals root 3. And in this one, you'd have sine x equals negative 1. So the question is, when is tan x root 3? And when is sine x negative 1? Well, you can put that in your calculator. You can go second function tan root 3. And so we get 60. Remember, there's always 2. So when is the other one positive? Root 3. And so remember, the 60 family is 60, 120, 240, 300. So we can put that in our calculator. Remember, it's not going to be 240 in the third quadrant. So we could try 300. Oh no, it will be. My bad. It will be 240 because it's 2 negatives in the third quadrant. So for tan, I was thinking cosine sine. All right, sine negative 1. We get negative 90 or 270. Remember, with negative 1 and 1, there's only one of them. So our answers for this one is 60, 240, and 270. Now, the only little trick that I wanted to show you on this was they said that our domain, or our range, was in between 0 and 2 pi. Well, if these are our answers, they want us to move this into radians. And when you move this into radians, you multiply 60 times pi over 180, and then 240 times pi over 180, and then 270 times pi over 180. So you got to convert all of those to radians. When you do that, you get your answer is so your answers are pi over 3, 4 pi over 3, and 3 pi over 2. 2 quick things to end this session is, first off, in lesson 65, the second part, it talks about graphing logarithms. If you graph a logarithm, it's the same way as graphing anything else, is you're just going to put it in your y equals and press graph and then draw it. But then the last concept is antilogs on lesson 67. Nothing to look at from lesson 66. But in lesson 67, They're going to tell you something like the base is 2, find the antilog of 4.63. Well, in order to understand how to do this, you got to go back to remembering how exponential form works. Okay, this is a logarithm problem. 2 is the base, 4.63 is the exponent or the log, and 24.76 is the antilog or the answer here to this problem. So whenever they say you have a base of 2, whenever they say you have a base of 2 and a log of 4.63, all you got to do is put that in your calculator of 2 to the 4.63 power. I mean, it's just a simple old exponential problem. Just to look at a couple more real quick, if you get a problem that says antilog 10 5.31, you can just go 10 to the 5.31, and it is a very large number. The other thing you can do is if they give you antilog e to the 2, you say second function e, and then you go to the 2, hit enter, and there would be your answer. If they say e to the negative 2, you would simply put that in there, and that would be your answer. These are not real tough, but they're just introducing the concept of what an antilog is and how to solve for it.